So my buddy's in town that's got the car wash. That car wash has the brushes that turn, and this is the motor that rotates those brushes, and this is like a 90 degree right angle drive, where this shaft is turning, and this is what's turning those brushes. And already we've got a failure with the cast aluminum here. And so they've got one side of the car wash shut down, and I need to get this figured out right away. Felt pretty sure that I want to disconnect this electric motor from this aluminum housing to be grinding and welding on this part of it. And we separated this when one of the owners was here, and I put it back together just to make sure that I knew how it went back together. So I'm going to take it apart again. I found the way I had the best luck putting it back together was putting this assembly with the pins together. And then the very last thing was assembling this keyway on this shaft that's got the keyway cut in it. Right there's the key. The way this works, there's this nylon bushing here, and it's got 3 pins. And those 3 steel pins are going into this coupler. And then there's 3 pins. There's 3 pins in here. When I put that back together, after I took it apart the first time, I assembled this section with the pins and the nylon and the coupler and the key on it. I put that in this housing, in this aluminum housing first, and then lined up this end lined up the key with the keyway cut in the shaft of that motor and put it together. So we had, there's 3 stainless steel bolts, and one of them is going to stay there. It won't come out unless you take this part off of this right angle drive. Here we see we have a keyway, metal coupler, the nylon bushing, which is this white or brown, light brown looking part. You can see the 3 pins going from the bushing into this coupler, and then the 3 pins sticking out go into the housing. I can't get that bearing off there, not without getting a little bit meaner than I have, and I'm afraid to do that. if I weld this with this housing together, there's an oil seal right here, and I need to weld right here. So I'm not crazy about it, but I'm not sure. I'm not sure what the highest level of risk is, because you know, if I mess up this bearing, I've already seen this thing's made in Italy. I've been online. It's all in Italian. You know, to find a bearing at the parts store that would match this, that's not going to happen. I'm sure this is all metric. It's just unlikely. I think I'm going to quit messing with that. I'm going to put this back together on top, put the oil back in it, reassemble it, and go from there. So since I've made the decision to weld this up with it assembled, the next thing is getting it in the right place. And obviously, you know, if I had the option, I'd want to do a bunch of beveling and stuff on that. But when you do that, you can't get your piece positioned in the right place. I'm putting it together the way I'm putting it together to get it tacked, and then I'll have to go back and do whatever kind of beveling or whatever I'm going to do, because if I do that now, I can't puzzle piece it together the way I'm doing here. See, I can tell by looking at that, I've got it in the right place because it fits together like a puzzle. Got that first one tacked on, and I did some MIG welding on the inside of it. So far so good. I'm going to tack that second tab back on there. So I put some weld on the other side, on the inside of this. And then I took my plasma and turned the plasma down pretty low and back gouged it. The spool gun, aluminum spool gun work I did on the back side was mixing with that cast pretty good. So I'm going to try some more. I'm going to try some more with that on this side. Don't mind me. I'm just TIG welding an Italian right angle drive gearbox sitting in a sour cream container full of water. Like, you know. Well, that's one. Miss Princess Diane's got this little area underneath the sink. She's got her food here. She always leaves this little bit in the bottom, and then when I come over here to put more in it, she'll start eating it. I don't know if she's saving that. If she's saving that as a reserve or what. And then she got her water fountain. This kind of water fountain comes with a spout, like a flower thing you can put on it. I think I probably got it right here. Yeah, this thing right here. And the water can come trickling down this, but she doesn't like this as well as just letting it do this. She likes all this space right here. And she'll play in that sometimes. She'll stick her paw in there. Won't you, Miss Diane? Miss Princess Diane. Well, she's busy eating. She's not going to pay any attention to us. Alright, I got to get to work. I've had a good little 7-hour break overnight, and I got up at 3 this morning. I got back online doing some looking about this gearbox, and there's a tag on the gearbox that I found. This tag that tells about the oil that's in it, and I was curious what kind of temperature that oil would withstand. And it's a Shell oil, Omala S4GX. That's not something we can buy in a little quart or something. It didn't look like, from looking online, this is an industrial oil that you buy in a drum or a 5-gallon bucket, or it didn't, from what I could see online, it didn't look like this was something I was going to run down to AutoZone and pick up a quart of. But it's just a synthetic gear oil, so it should last forever. But my curiosity, really more than anything, since I wasn't able to take this completely apart to weld on it, I wondered what kind of heat that oil would take. And the information I found online said that it would withstand 120 Celsius. And I went on and converted that, and I come up with 248 degrees Fahrenheit. And I don't think I got this gearbox that hot. Obviously, the part of this housing that I was actually welding on was obviously that hot. But the gearbox itself, I don't think was. So I was looking this morning, I was looking about that, and also I was looking at this, I had concern for that seal. This is that oil seal. And what I'm noticing this morning, looking at this oil seal, there's part of this, like, to me, that part of that oil seal has pressed out. See, if you look at the one that's not welded yet, see how that seal's flush? So what does that mean? Well, it means that the heat did create some pressure inside this gearbox, and it pushed on that seal, which sounds like it's a really bad thing, but I tell you what, there's not oil running out of this gearbox right now. And that to me is a very good thing. Because, if I was able to weld on it and not see oil come out of it, and there was enough pressure inside of it to push that, if the heat caused enough pressure in here, which obviously any heat inside of any vessel that's sealed is going to create some pressure. But if it backed that seal out that much, I tell you what, if this thing was going to leak, it'd be leaking right now. That's what I'm thinking. I'm thinking this thing will never see the pressure in operation, the kind of pressure that it was, withstanding from the heat of welding on it. And so it's bad and it's good. Now the next thing is, I went and got a soft pine shim, and I was wondering, like, should I tap on that and try to press that seal back in? I might do that a little bit, but overall, my thoughts are going back to the same thing. It's not leaking oil. I've had to have created some pressure in it by warming it up during the welding, and I've created enough pressure to push out on that seal a little bit. But there again, I'm saying, even with that, it's not leaking oil. So I don't want to mess with it too much. That's pushing that right back in there. and I'm not seeing any damage to it. Pushing that right back in there flush. Check this out. So we're right back in there flush where it was. And I'm not gonna mess with it any more than that. I'm tickled with it. I mean, I think it's good. I think it's a good scenario. Considering, you know, that I wasn't able to get that completely apart, I feel pretty fortunate that I got it welded up like I did and don't have a problem yet. And like I say, it's interesting that I've put some pressure in there and I haven't leaked any oil. And thinking about the oil being inside of it, you know, you kind of want to think, well, maybe you should release it. Maybe you should loosen that fill plug or something so there's not pressure in it. But if you do that and you're rolling it around like I have to do to weld on it, it's going to leak out. And then you've got the risk of aluminum oxides and stuff getting in. And what it's reminding me of right now is an old trick I seen welders do where, I've seen welders, they'll freak people out by taking a foam coffee cup and putting it on their vise on the back of their truck and filling it up with water and taking an oxyacetylene torch and feathering that cup full of water. And if you do that carefully and you do it just right, you can boil water in a foam coffee cup. And you think, man, there's no way you could do that. But there's been plenty of welders that won plenty of money betting people that they could boil water in a foam coffee cup and doing it. So how, you know, scientifically, how could that be possible? How can you boil water with a torch in a foam coffee cup? Well, the water that's in the cup is controlling the temperature of the foam. When that cup is filled with water, now obviously if you had an empty coffee cup, if you had an empty foam coffee cup and you feathered a torch at it, it would just melt. But when that thing's full of water, the only way you're going to get that foam cup hot enough to melt it is to get the water hot enough to melt foam. Because the volume of water compared to the amount of foam that's there, the volume of water is a lot. And it takes more heat to melt foam than it does to boil water. And that's why you can boil water in a foam coffee cup with an oxyacetylene torch. And that same concept, I think, is taking place on this gearbox and this seal. This contains an oil that's safe for operation purposes up to 248 degrees Fahrenheit. And that oil is surrounding that oil seal. So I can't get that oil seal hot enough to melt it, hot enough to ruin it, when it's being protected by that volume of oil on the other side. I'm assuming that's what's happening. I'm still going to be really careful. I cooled it down a bunch of times when I was welding on it yesterday. I'm going to put this one back together. Then I'm going to disassemble and weld the other one. So that's coming up. I'm noticing that through the repeated sanding and cleaning that I've done, I've made this corner thinner. See how thick that is back there? So on these two where I've done the repair, I'm going to cut a couple little gussets and put on top of there and TIG them on there for that bolt to rest on. I've talked to several of my buddies here and there and mentioned about cutting this sheet aluminum with woodworking tools and working it with woodworking tools. And a lot of people seem to be unaware that you can do that. But any of these woodworking tools with the carbide teeth, doesn't matter if it's a circular saw, jigsaw, even a router, cuts aluminum really good, does a nice job. I think this is amazing. See those three little pins? They go in those tiny little holes. Those three pins is what's driving that whole brush. And the way this worm gear is, screw gear, whatever you call it, in here, if you try to turn this big shaft, you can't even move that little one. But I can stick my finger in here and almost effortlessly crank that big shaft. I'm just pushing on that with light finger pressure, and I can turn that thing like nothing. The power of gears and gear reduction. Unreal. Got to put this back together. This is the anti-seize with the copper. The aluminum anti-seize, the silver stuff's good too. This is what I've got a lot of. There's this one bolt, never did come off the thing. And I think I found the best way to put this together. Is to go ahead and put it in the gearbox. I'm going to put a little bit of bearing grease on it. This had grease on it when I took it apart. I know this shaft goes opposite the electrical, but we can turn that when we get to that point. Got to get that keyway lined up. Then you can rotate till the bolts line up. There's an O-ring that goes in there. That'd have been a goof to leave the O-ring out. I gotta look at things when I'm doing it, you know, because you look at that and realize you're missing something. Grease is a pretty handy as a temporary glue too. You keep things in place with it. It should keep that, you know, it's keeping grease on those pins. It's good to keep the pins from corroding where I'm putting that together, but it also keeps that assembled while I'm flipping it upside down and then hopefully some grease on that O-ring. That can help keep it there. it. Just got this second one apart, and I found something interesting. It's not really a problem, but those pins are staying in there. You know, on that other one they pulled right out. So I had them out, and I had them in the Ziploc bag on that other one the whole time I was welding on it. I even pulled on these with the needle nose with the pliers, and they're really in there. That's not a problem, but they need to stay in there. Even, you know, if we lose one of those pins, that's probably some metric pin that I'm not going to find. So I'm leaving them in there, but while I'm rolling this around and welding on it, I'm going to stuff that rag in there, and I used these two screws right here, and I made up a gizmo that's going to cover that up. I don't want there to be any chance of those pins coming out of there while I'm working on this thing. Just finished welding on the second gearbox. A lot of porosity in that cast, so I'll reassemble this one. That'd be the next thing. I didn't lose the pins. My little rag and my shim gizmo worked. All right. That one's put together. So that's going to go on that car wash, that bay that's shut down right now. And I guess if that works, we may end up doing that to the other ones. That's obviously an issue with these things, and the tech that services that equipment that the owner had talked to said that that's really common. They break those these people with these certain vehicles, like a Jeep with certain kind of bumper and big tires, it tricks the sensors of that car wash, and the brushes move in because the sensors are being fooled by the shape of that odd vehicle, and the brushes end up spinning around and getting thrown up underneath a big Jeep tire. It gets stuck, and it jerks on that assembly. Of course, that big brush is bolted to that flange and hangs down, and all that weight comes to a screeching halt, and it really jerks on that. So I don't know, we'll see how this works out, and we may end up doing another set of these for that other bay. And I think it welded up pretty good for cast aluminum. I ended up using the spool gun and the TIG. Obviously you get a lot of porosity and defects with the spool gun, but it puts a lot of meat on there real quick, and it's kind of an efficient way to fix cast, an efficient way to fix aluminum is to use a combination of both, because the TIG welding is obviously slow, and if you've got a lot of it to do and you can feed a bunch in with the spool gun, and then repair any of your defects with the TIG, that works real well. So that's it for this one.